Okay, here are the 7.2 notes, page 3. More practice with the trig ratios. So here's our first triangle. We've got two legs, side A and B. A is 16, B is 12. So to find the hypotenuse, we're going back to the Pythagorean theorem. So I've got A squared plus B squared equals C squared. We're looking for the hypotenuse again. A is 16, B is 12, 16 squared is 256, 12 squared is 144. When we add those together, we get 400. That means when we square root both sides, we get the length of the hypotenuse is 20. Always kind of nice when we're just using whole numbers. So the sine of theta. Theta is down in this bottom left corner. Opposite over hypotenuse, we get 12 over 20. We always want to reduce if we can. That reduces to 3/5. Cosine adjacent over hypotenuse, we get 16 over 20. We reduce that and we get 4/5. Tangent of theta, opposite over adjacent, 12 over 16. And we reduce that to 3 over 4. So on the right side here, we have those reciprocal functions. Cosecant of theta is then the reciprocal of the sine, so 5 over 3. Secant is reciprocal of cosine. We get 5 over 4. And cotangent is the reciprocal of tangent, 4 over 3. And that's it. Okay. Example 4. This time we are given two of the trig functions. We don't have a picture, so the very first thing we're going to do is draw that picture. So I am going to draw a right triangle. Doesn't really matter how I orient it. Here's my right angle at C. I'm going to make this angle down here theta. If sine is 4/7, that's opposite over hypotenuse. I know that if this is going to be my angle theta, my opposite side is going to be length 4. My hypotenuse is going to be 7. Tells me that the cosine is square root of 33 over 7. That means my adjacent side is square root of 33. My hypotenuse is 7. Notice here we have all three sides labeled. You can assume that there are no trick questions. I haven't screwed something up, but we can always double check and make sure that the square of the two sides equals the square of the hypotenuse. I get 33 plus 16. That equals 49, so we're good. So now I'm going to just start filling these in. Notice these trig functions are ordered a little differently. Cosecant, though, is still the reciprocal of sine, so the cosecant is 7 over 4. Tangent is still opposite over adjacent, 4 over the square root of 33. Again, we don't like that radical in the denominator, so when we rationalize, we end up with 4 square roots of 33 over 33. Secant is the reciprocal of cosine. So I've got 7 over 33, square root of 33 down here. When we rationalize that denominator, we get 7 square roots of 33 over 33. Cotangent is going to be the reciprocal of tangent. I'm going to go back to that original form, 4 over square root of 33. That's the one I am going to invert and get square root of 33 over 4. Okay. Exercise 5, same thing, except here we're only giving one of those trig ratios. So I'm going to go ahead and draw my triangle right here. I'm going to call this one theta. Doesn't matter, I could call the top one theta if I wanted. Opposite side is square root of 2. Hypotenuse is 2. And so here I have a leg and the hypotenuse. So I definitely need to solve for that other leg. And so I'm going to stick square root of 2 in for B. It could go in for A. It doesn't really matter. Keep in mind these labels are fairly arbitrary. What's important is that we can decide or determine which is the opposite side, which is the adjacent side, and which is the hypotenuse for any given side. So it looks like this other leg is also the square root of 2. Okay, so now we have all three sides of our triangle. And now we need to fill in. Cosine adjacent over hypotenuse. Here is our adjacent for theta. And so the cosine looks exactly like the sine, square root of 2 over 2. Tangent, opposite over adjacent. We got square root of 2 over square root of 2. Anytime we divide a number by itself, we just get 1. Cosecant is going to be the reciprocal of sine. So I've got 2 over the square root of 2. Again, I'm going to rationalize that denominator by multiplying the top and the bottom by the same thing. I get 2 square roots of 2 over 2. Our 2's cancel, and we get square root of 2. Secant, 1 over cosine. It's going to look exactly like the cosecant, yeah? And cotangent, 1 over tangent, we get 1. So I threw a couple of things at you that you may or may not remember, but they're going to come in handy as we move forward. 2 things you really need to remember. When you're asked to solve a right triangle, that means you may be given some information. We want you to find all of the sides, all of the angles, okay? So you're probably going to end up using Pythagorean theorem. We saw that in play. A and B are the lengths of the legs. A squared plus B squared equals C squared, where C is the length of the hypotenuse. The other thing we're going to use a lot is the triangle sum theorem. And that just is a reminder that the 3 interior angles of a triangle add up to 180. So here where we're talking about right triangles and we have that 190-degree right angle, that means our other 2 angles have to add to 90 degrees. And if you remember back to your geometry, any 2 angles that you can add together and get 90 are called complements. That's it. See you on page 4.